Okay, so this is the ballistic pendulum experiment. Um, I understand that this is a bit weird. Um, I'm doing this mainly just to think or to feel like I'm still actively involved here. So I'm going to try to keep these videos short, hopefully under 10 minutes. So I'll just start going through the process. So download the lab, and what I'm going to do is run through the experiment and hopefully let you make the measurements. I'm going to indicate where the measurements are and where to read them, and I'll let you decide what the measurement is and then go through the calculations. So for this lab, it's the ballistic pendulum. So it's in the book, it is example 7.9, okay, where they run through the derivation here, finally to get down to this equation here for the speed of the incoming projectile, okay, where little m is the mass of the projectile, big M is the mass of the pendulum arm, and h is the final height. Okay, now for this lab, we're going to be going by the angle. So this is my derivation for the angle. Okay, length of arm, L, h is the height, theta is the angle at the top. You make a triangle by bringing h over to this side. So this top right triangle is L minus h, and then L on the hypotenuse. You just use the cosine to solve for h in terms of L. Okay, now how this works is you load the ball, that's the projectile, into the spring chamber, and you fire it. So the speed coming out of the spring chamber, that's the initial speed of the projectile. Then, if you can see it, then this the pendulum arm actually captures the ball, and then it swings up to a certain height. And this nifty device here, so you don't even really have to go full live with it, but it will measure the highest theta on the arm. Okay, so I don't have time to go into all the derivations here, but basically there's two things happening: the momentum collision between the projectile and the pendulum arm. Okay, so work your way through this, and then so that's momentum, and then the combined mass, that's why you see m, little m plus big M everywhere, then that swings up to a certain height, and that's a conservation of energy problem on this side, and that's a familiar result for us. And then you plug this back in to get the solution here for the initial projectile speed given h. You plug h in up here from your measurements for L. Okay, so let's make some preliminary. We need the mass of the projectile. So we're just going to get a measurement here. We'll go with 66 grams, or 65.9. Remember, you need kilograms. We also need the length of the lever arm. So I'm going to put it about right there. So it's hard to see. We'll call that 31 centimeters. So 0.31 meters. Okay, now we'll just get to the, so for the lab it says ball 1, ball 2, and ball 3, but I'm going to use the same ball on the 3 different settings. Okay, so we'll just get through this here. I'm going to have to set the phone down occasionally. Okay, so now that's loaded up to the first setting, and I'll reset the reader. We'll go ahead and pull it. Now if it doesn't capture, that happens sometimes, you just have to try again. Okay, so here we go for number 2 on that one. Okay, so that's, let's see, is it going to focus for me? Okay, it doesn't want to focus. right, well, let's call that 18 degrees. So 18 degrees for the first one. Okay, now for the second setting. I'll call that 32 and a half degrees. And we'll go for the third setting. Okay. And it's basically the same exact spot there. Let me make sure I got the actual third setting on that one. Okay, try this again. Okay, there we go. So for the third setting, we'll go with 37. There you can see it there, 37 degrees. Okay, now for the second part, because we want to try to measure this the speed a different way to compare. So I'm going to take out the pendulum. Okay, now we're going to do this using projectile motion. So this is something we would have done a long time ago, where it's a horizontal projection. So initial horizontal speed, we're going to measure the delta y and the delta x, and then calculate the initial speed, delta x over t, using the second kinematics equation for free fall. Solve for t. Remember the negatives because delta y is going to be negative, and plug that t back up into that equation. So we get this equation for initial speed. Okay, so first we need the height. First we need the height. Let me move this toward the edge here. Okay, and we need the height above the ground. So I'll try to, you want to get this to the center of the tube there, or let's say the bottom of the tube. So this is 80, and let's call it 83. That's about the right level. 83 centimeters. So that's delta y for all three. And now we'll load up again for each setting, and then we'll measure along the floor there the delta x. Okay, so this is going to be much more of an estimate, but we'll just use the numbers. So here we go with setting 1. I'll go with, now this is inches, 37 inches, so you'll have to convert that to meters first. I couldn't find a tape measure with meters. Okay, so for setting 2, okay, here we go for setting 2. And I didn't pay attention. I think it was about 73 inches. And that landed right in the track, so that was kind of a miracle. Everybody saw that. Now let's go for setting 3. Okay, and now for setting 3. That was a misfire. One more time. Okay, setting 3 again. Okay, it goes about 82 inches. Okay, so that should be it. Just make sure you submit that lab and email me with any questions. Thanks.